All right, kids, here we are, or adults and others. So this is the pit that I have dug. So the reason that we're doing this is that after, I don't know how many years of taking many of you on field trips, the one thing I learned is after 5 minutes of discussing the outcrop, that the bottom line in the whole thing is then all you want to do is either wield your hammers on the outcrop or throw rocks at each other. So one of the things for those of you that aren't geologists watching this, that geologists love to do, is throw rocks. So the question that's going to be coming up shortly, which I'll read at the end of this, basically has a lot to do with what you see down there in the pit. Those guys, the dinosaurs. And if you know anything about dinosaurs, you will right away be able to tell what the time frame is. Here we're dealing with sandy loam, which is pretty dense stuff, about 1.3, 1.4 on the density scale. I'm going to try and compensate. 9.8 meters per second squared is not going to change. Meteorites come in probably a little faster than that, and they usually explode in the atmosphere. So that reality is kept in touch. Rocks will not explode. And the final part of this is the coating on top. It's a snowy day in dinosaur land, is flour. So the first thing we're going to do is we're going to take this beautiful round meteoric cobble, which weighs about 10 pounds. You heard that. Whatever. This is a glacial cobble. It has absolutely nothing to do with reality and whatever. And we're just going to drop it on part of the pit. Here we go. Oh, wow. So the next thing is, for those of you that are geologists, you recognize that one of the questions that could be is, how old is this rock and where did it come and what's its common name? Well, I'll answer that for you. The common name is it's a Gaugandatillite, and it's a mafic Gaugandatillite. And the dinosaurs are covered in flour, which means that one of them fell over. Actually, the pressure wave has knocked the dinosaurs over, and the tillite is now in the pit. When was the last mass extinction event, millions of years, attributed to a meteorite? And the bonus part of this question, for those of you that want to go on the internet and try and find out, were there any other geological factors that are thought to contribute to this mass extinction?